Hello student, today we take first chapter of NCERT book, Real Numbers. Real Numbers. And we take exercise number 1.1. First question. Use Euclid's division algorithm. Find the HCF of 1. First question, first part, we have to find out HCF of 135 and 225. We have to find out HCF. First of all, we should know what is HCF. H means highest, C means common, F means factor. Highest common factor. It means इन दोनों नंबर्स में का फैक्टर करेंगे और इन दोनों में फैक्टराइजेशन के बाद में जो सबसे बड़ा हाईएस्ट कॉमन फैक्टर होगा वही हमारा HCF होगा। लेकिन हम यहाँ पर फैक्टराइजेशन मेथड यूज नहीं करना हम लोगों को, यहाँ पर हम लोगों को लगाना है यूक्लिड्स डिवीजन एल्गोरिथम। अब यूक्लिड्स डिवीजन एल्गोरिथम क्या है, देखने में बहुत बड़ा सा लग रहा है लेकिन है ये बहुत छोटी सी चीज। हम लोग क्लास 4 में इसको पढ़ चुके हैं और देखते हैं ध्यान से। सपोज दैट वी हैव टू डिवाइड 5 बाय 2। नाउ 2 2 जा 4, 5 minus 4 दिस इज इक्वल टू 1। 2 यहां पर डिवाइजर है, जिस चीज से हम डिवाइड कर रहे हैं वो हमारा डिवाइजर है। तो यहां पर हम इस तरह से इसको कह सकते हैं 2 इज डिवाइजर। दिस 5 इज डिविडेंड एंड दिस 2 इज कोसेंट एंड दिस 1 इज रिमाइंडर। फिर से देखते हैं इसको। जिस नंबर को डिवाइड करना होता है उस नंबर को हम डिविडेंड बोलेंगे, जिससे डिवाइड करेंगे वो नंबर हमारा डिवाइजर होगा, जो ये होगा वो रिमाइंडर होगा और ये होगा हमारा कोसेंट। अब जैसा कि हमारे टीचर ने हम लोगों को पढ़ाया है, वी नो दैट डिविडेंड इज इक्वल टू डिवाइजर into quotient plus remainder We have already studied about this in our previous class. If remainder is denoted by R, divisor is denoted by B, dividend is A and quotient is Q, then we can write here A is equal to divisor means B, quotient means Q, plus remainder means R, and this is our Euclid's division algorithm. इसी को हम यूज करेंगे और यूज करते हुए हम HCF फाइंड आउट करना है। In this question, we see that 135 is less than 225. Therefore, we divide 225 by 135. 135 हो गया 135. 5 minus 5 this is equal to 0. 12 minus 3 this is equal to 9. We can write here 225. This is equal to divisor into quotient. Divisor means 135 into quotient means 1 plus remainder, and this remainder is 90. Again we divide 135 by 90. 91 the 90 and then we have 45. We can write here this is our first step And now this is our second step. 135. This is equal to 90 into 1. 90 into 1 plus 45. Again, we divide 90 by 45. 45 1 ja 45. 45 2 ja 90. And now we have 0. When remainder is 0, division process stops. Now here remainder is 0. 90, this is equal to 45 into 2 plus 0. Here we see remainder is 0. When remainder is 0, 45 is divisor. Therefore, this is our SCF. SCF is equal to 45. And this is our answer. Let us see third part of first question, that is we have to find out HCF of 866 and 255. Here we see 255 is less than 867. Therefore, we divide 867 by 255. 255 3 ja 3 5 are 15. 25 3 are 75 plus 1 76. 7 minus 5 we have 2. 6 minus 6 0. 8 minus 7 1. Now we can write here 867. This is equal to divisor into quotient. 255 into 3 plus 102. Now we divide 255 by 102. 102 2 ja 204. 5 minus 4 is equal to 1. 5 minus 0 is equal to 5. 2 minus 2 0. Therefore, we have 255. This is equal to 102 into 2 plus 51. Again, we divide 102 by 51. 51 2 ja 102. Then we have 0. Here we see remainder is 0. It means 51 is our SCF. Then we write here 102. This is equal to divisor into quotient plus remainder. Here remainder is 0. Therefore, 51 is our answer. It means FCF. This is equal to 51. And this is our answer. Write it. Now, we see question number 2. Question number 2 says, so that any positive odd integer is of the form of 6q plus 1 or 6q plus 2 or 6q plus 5, where q is an integer. Here we have been given 6q plus 1, 6q plus 3 and 6q plus 5 are integers. Let any positive odd integer is a is equal to bq plus r. B BQ plus R. Let any positive odd integer is A is equal to BQ plus R. Here we take only positive integer. Let any positive integer is A is equal to BQ plus R, where B is equal to 6 and we know that the remainder is always 0 or less than divisor, and here divisor is 6. Therefore, R should be 0, 1, 2, 3, 4 and 5. But here we have to take only 1, 3 and 5. Where when R is equal to 1, then A is equal to 6Q plus 1. Let us see, we can write here 6 as 2 into 3. 2, 3 is 6. 2 into 3Q plus 1. 2 into 3Q plus 1. We see that 2 is a factor of this number. Therefore, this number is divisible by 2. Therefore, this is even number. And we know even plus 1. और जैसे ही हमें पता है, जैसे ही हम इवन में 1 नंबर ऐड करते हैं, 1, then we get odd. Therefore, this is odd. We see that 6Q plus 1 is an odd integer. Again, when R is equal to 3, then A is equal to 6Q plus 3. We write here 2 into 3Q plus 2 plus 1. 3 को हम राइट कर सकते हैं 2 plus 1. And in these two steps, we see that 2 is common. Therefore, we take 2 as common. Now we have 3Q plus 1 plus 1. We see that 2 is a factor of this number. Therefore, this number is also divisible by 2. And we know when any number is divisible by 2, then that number will be an even number. Therefore, this is even number. And even plus 1, that is equal to odd. Therefore, this is also an odd number. Now we take R is equal to 5. Then A is equal to 6Q plus 5. 6 means 2 into 3Q and 5 means 4 plus 1. Now we take 2 common. 2 is common. Then we have 3Q plus 2 plus 1. We see 2 is factor of this number. Therefore, this number is divisible by 2. Therefore, this is an even number. And even plus 1. This is equal to R. Therefore, we can say any positive or integer, any positive or integer is of the form of 6Q plus 1 or 6Q plus 3 or 6Q plus 5, and this is our now we see question number 3. Question number 3. An army contingent of 616 members is to march behind an army band of 32 members. In a parade, the two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? we have to find out maximum number of columns. So according to question, maximum number of columns is equal to HCF of 616 and 32. We use Euclid's division algorithm and find the CF of 616 and 32. We see that 616 is greater than 32, therefore we divide 616 by 32. 32, 1 ja 32. 11 minus 2, that is 9. 5 minus 3 is equal to 2. Now we have 6. 9 times. 9 2 ja 18. 9 3 ja 27 plus 1 28. Now we have 8. We can write here 616 is equal to. This is divisor, quotient, remainder. Therefore 32 into 19 plus 8. Again we divide 32 by 8. 8 4 ja 32. Now remainder is 0. Division process stops here. We know that division process will stop when remainder is 0 or remainder is less than divisor. Therefore 32 is equal to 8 into 4 plus 0, where remainder is 0, divisor is 8. Therefore HCF of 616 and 32 is equal to 8. Therefore maximum number of columns will be 8, and this is our answer. Now we take question number 4. We take question number 4. Use Euclid's division lemma to show that the square of any positive integer is either the form of 3m or 3m plus 1 for some integer m. Let any positive integer A is equal to BQ plus R. Let any positive integer is A is equal to BQ plus R, where B is equal to 3, then R is equal to 0, R less than 3, it means 1, 2. When R is equal to 0, then A is equal to 3Q plus 0. That means A is equal to 3Q. Now we have to find out square of this number. It means, therefore, A square is equal to 3Q whole square. 3 square is 9, Q square is Q square, and we can write it 3 into 3Q square. It means this number is multiple of 3, and we can write it 3m. M for any number, any integer. It means this number is multiple of 3. Therefore, we can write it 3m. A square is equal to 3m. When R is equal to 1, then A is equal to 3Q plus 1. Now we find A square. That means 3q plus 1 whole square. Now we use here the identity a plus b whole square. And we know a plus b whole square, this is equal to a square plus 2ab plus b square. A plus b whole square. We use that identity. A square means 3q square. 3q square means 9q square plus 2. A means 3q. B means 1 plus b square means 1 square. In these two steps, we see that 3 is common. 3 is common. Then 3q square plus 2q plus 1. We see that this number is multiple of 3. This number is multiple of 3. Then we can write 3m. Any multiple of 3 plus 1. Here we should know that m means 3q square here, and here 3q square plus 2q means m is not 3q square. M means any integer that can represent 3m as multiple of 3. Then we take when r is equal to 2. Then a is equal to 3q plus 2. Therefore, a square, this is equal to 3q plus 2 whole square. Again, we use this identity a plus b whole square and a plus b whole square. A square plus 2ab plus b square. Here a square means 3q square. That is 9q square plus 2. A means 3q, b means 2 plus b square means 2 square. In these two steps we see 3 is common. 3 is common. Then 3q square plus 2 to the 4q plus 4. This number is also multiple of 3. We can write 3m plus 4. 4 means 3 plus 1. 4 means 3 plus 1. We should write here this. 9q square plus 2 3 6 to the 12q plus 4. 9q square plus 12q plus 3 plus 1. Now in these three steps we see that 3 is common. Here 4 means 3 plus 1. It means 4 को हम 3 plus 1 लिख सकते हैं. अब हमारे पास 3 steps हैं. In these 3 steps we see that 3 is common. Therefore we take 3 as common. Then we have 3q square plus 4q plus 1 plus 1. And we see that this is multiple of 3. Therefore 3m. This number is multiple of 3. We can write 3m plus 1. Therefore, we see that square of any positive integer is of the form of either 3m or 3m plus 1. This is our answer. Now we see question number 5. Question number 5. Use Euclid's division lemma to show that the cube of any positive integer is of the form of 9m plus 1 or 9m plus 8. Question number 5. Let any positive integer a is equal to b cube plus r, where b is equal to 9 and then r is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. We know that r should be 0, r should be less than b. B is divisor and here divisor is 9. Therefore, r should be 0, 1, 2, 3, 4, 5, 6, 7, 8. When r is equal to 0, then a is equal to 9 cube plus 0 is 9 cube. Then a cube is equal to 9 cube whole cube. 9 cube 729 cube. We can write it 9 into 81 cube. It means this number is multiple of 9. Therefore, we can write it 9m. Again, when r is equal to 1, then a is equal to 9 cube plus 1. Therefore, a cube is equal to 9 cube plus 1 whole cube. Here, we use another identity, that is a plus b whole cube. This is equal to a cube plus b cube plus 3ab into a plus b. We know that identity and we use here. Therefore, a cube is equal to a plus b. See, a plus b, a cube, 9 cube plus b cube, 1 cube plus 3. A means 9 cube, b means 1 and a plus b, 9 cube plus 1. 9 cube 729 cube plus 1 plus 27 cube into 9 cube plus 1. 729 cube plus 27 cube into 9 cube plus 1 plus 1. In these two steps, we see 9 is common. 9 is common. Therefore, we have 81 cube plus 9 theta. 3 cube into 9 cube plus 1 plus 1. We see that this number is multiple of 9. Therefore, we can write it 9m plus 1. Again, when r is equal to 2, then a is equal to 9 cube plus 2. Therefore, a cube is equal to 9 cube plus 2 whole cube. Again, we use this identity, a plus b whole cube. This is equal to a cube plus b cube plus 3ab into a plus b. And we use it, a cube, 9 cube whole cube plus b cube, 2 cube plus 3a, 9 cube, b2, a plus b, 9 cube plus 2. 729 cube plus 9 theta, 27 to the 54 cube into 9 cube plus 2 plus 8. We see here 9 is common in these two steps. Therefore, we take common 9. Then we have 81 cube plus 6 cube into 9 cube plus 2 plus 8. What do we see here? We see here that this number is multiple of 9. Therefore, we can write it 9m plus 8. We see that cube of any positive integer is of the form of 9m plus 1 or 9m plus 8. Therefore, cube of any positive integer is of form 9m are 9m plus 1 are 9m plus 8, and this is our answer. Write it.